Welcome to this video on the language of hypothesis testing. After watching this video, you should be able to define hypothesis testing, state the null hypothesis for all hypothesis tests, state the three possible alternative hypotheses for hypothesis tests, state the two different types of population parameters that can be used in hypothesis tests, and write the null and alternative hypotheses for a hypothesis test. What is a hypothesis? A hypothesis is an educated guess based on unbiased evidence. What is hypothesis testing? According to Sullivan, hypothesis testing is a procedure based on sample evidence and probability used to test statements regarding a characteristic of one or more populations. We use very specific and careful language in hypothesis testing. We say there is sufficient evidence to support the claim, or we will say that there is insufficient evidence to support the claim. It can be useful to think of a hypothesis test as a court case. Steps of hypothesis testing, a court of law. The first thing we do is to make a statement regarding the nature of the population. This is analogous to a person pleading guilty or innocent to a crime. We then collect and examine evidence to test the statement. This is analogous to the process of attorneys collecting and presenting evidence to support their case. We then analyze the data to assess the plausibility of the statement. This is analogous to either a judge or a jury weighing the evidence and deliberating over the evidence. Lastly, in a hypothesis test, we make a statement about the hypothesis. This is analogous to the part of the court of law where the judge or jury pass a verdict, guilty or not guilty. The burden of proof. Can you prove that someone is innocent? Two outcomes of a court case are guilty or not guilty. Is not guilty the same as innocent? Pause this video for a second and think about this question. You cannot prove that someone is innocent, but you can fail to prove they were guilty. In this case, you would say that there was insufficient evidence to convict them of the crime. You are not proving their innocence, you are merely failing to prove their guilt. This is a subtle but important distinction that also exists in the world of hypothesis testing. The null and alternative hypotheses. The null hypothesis. This is represented by the symbol that is a capital H with a lowercase o, and the way this is read is H naught. Naught is N-A-U-G-H-T, and it literally means nothing. So we say H naught. This is a statement of no change, no effect, or no difference. This statement, the null hypothesis, uses an equals sign. We never prove the null hypothesis, just like we cannot prove that someone is innocent. We merely fail to disprove the null. We also sometimes say that we retain the null hypothesis. Let's look at the alternative hypothesis. This is represented by the notation H1, or in some textbooks you might see H sub A or HA. This is the statement we are trying to find evidence to support. The alternative hypothesis uses either a less than sign, a greater than sign, or a not equal to sign. Notice that it never uses an equality sign, and it doesn't use an inequality that contains an equality. In other words, we never use the less than or equal to sign, and we never use the greater than or equal to sign in an alternative hypothesis. We can, in fact, prove the alternative hypothesis, just as we can prove that someone is guilty. The null and alternative hypotheses. In a U.S. court of law, a person is innocent until proven guilty. In terms of hypothesis testing, we say the following. The null hypothesis, H naught, is that a person is innocent. We assume this is true until we prove otherwise. Again, we assume that it is true. We do not prove that a person is innocent. The alternative hypothesis, H1, is that a person is guilty. If sufficient evidence is gathered against the defendant, the person is no longer assumed to be innocent. They are found to be guilty. True or false? Sample evidence can prove the null hypothesis true. Pause this video, answer this question, and then unpause it to see if you are correct. If you said false, then you are correct. Remember, we said that we can never prove the null hypothesis. We merely fail to disprove it, just as in a court of law, a person is not proven innocent, but is declared not guilty. We do not prove a person's innocence, we fail to prove their guilt. Ways to set up hypothesis tests. There are three types of hypothesis tests. There are left-tail tests, two-tail tests, and right-tail tests. Let's begin by looking at what a left-tail test means. In a left-tail test, we have a critical value that separates the left alpha area from the rest of the area in the graph. In a left-tail test, our null hypothesis is H0. It states that the parameter is equal to some value. Then we have our alternative hypothesis, H1, which states that the parameter is less than some value. Again, because it is a left-tailed test, we are shading to the left of the critical value, and therefore we are using the less than symbol in our alternative hypothesis. The keywords to look for to know that you will be doing a left-tailed test are decreased, fewer, or less. Let's look at a two-tailed test. In a two-tailed test, we have two equal but opposite critical values that separate two tails of the probability distribution. Notice that our alpha is divided equally between these two tails. Therefore, the area to the left of the critical value is alpha over 2, and the area to the right of this critical value is also alpha over 2. Just as before, our null hypothesis is that our parameter is equal to some value. However, this time, our alternative hypothesis is that the parameter is not equal to some value. We use the symbol not equal to indicate that we have to consider both possibilities that a value has decreased, which would be a left-tail test, and the possibility that the value has increased, which would be a right-tail test. The key words to look for in a two-tailed test are changed or different. Let's now look at a right-tailed test. In a right-tailed test, we have a single critical value that separates the top alpha part of the probability distribution from the rest of the curve. Again, our null hypothesis is still that H0 is still H0, and it says that the parameter equals some value. Notice that the null hypothesis in all three tests is exactly the same. The only difference among these tests is the alternative hypothesis. In a right-tailed test, as you can see, we use the greater than symbol because we are shading to the right of this critical value. Keywords to look for to know that we are going to do a right-tailed test are increased, more, or greater. In addition to considering whether we are performing a left-tailed, right-tailed, or two-tailed test, we must also consider what type of data we are being given. Remember, the two main types of data are categorical, also called qualitative, which are labels. The other type of data is quantitative, which are counts and measures. If we have categorical or qualitative data, we have a population proportion as our population parameter, and therefore we use the symbol P in all of our hypothesis statements. If, on the other hand, we are working with quantitative data, such as counts or measures, then our population parameter is the population mean, and we use the symbol mu, the Greek letter for M, to represent the population mean. This is the symbol that should be contained in all of our hypothesis statements. So let's look at what hypothesis statements look like for categorical data. Again, if we have categorical data, we will be given proportions. So our null hypothesis, if you look across the board, all say that P, our population proportion, will be equal to some value that will be given to us. Notice that our alternative hypothesis also always contain this P character, which again stands for our population proportion. In a left-tailed test, we'll have P is less than some value. In a two-tailed test, we'll have P is not equal to some value. And in a right-tailed test, we'll have P is greater than some value. What about quantitative data? What would those statements look like? Well, notice that everything is exactly the same except for the symbol. Now that we have quantitative data, we will be looking at a population mean and testing the truth value of the population mean based on some sample data that we are being given. So notice all of our null hypotheses are exactly the same. Mu equals some value. Again, they're the same regardless of whether we're doing a left-tailed, a right-tailed, or a two-tailed test. What changes is our alternative hypothesis. So if we have a left-tailed test, we have our mu, our population mean, less than some value. If we have a right-tailed test, we have mu, our population mean, greater than some value. And if we're considering both possibilities, then we have a two-tailed test and we have our mu, our population mean, not equal to some value. State the null and alternative hypotheses. Let's practice writing our hypothesis statements in specific examples. 5 years ago, a company conducted a satisfaction survey among its customers and found out that 83% were very satisfied with their product. The company wants to find out if the proportion of satisfied customers has changed since then. Step 1 is to determine whether we are working with categorical data, meaning that the population parameter would be the population proportion, or whether we have quantitative data, which would mean that our population parameter would be the population mean. That way, we can know whether we should use p or mu in our hypothesis statement. Notice that the question says that 83% were very satisfied. You might realize that 83% is a proportion, and also that the phrase very satisfied is a sign of categorical data. In other words, it is a label, not a count or measure. Therefore, the appropriate population parameter for this problem is the variable p. Once you have decided whether to use either p or mu in the hypothesis statements, you can start writing the null and alternative hypothesis statements. The null hypothesis always contains the equal sign. Then you have to use the keywords from the problem to determine which inequality sign, either less than, greater than, or not equal to, is appropriate for your alternative hypothesis. In this question, the word changed does not imply either decreased or increased, so we have to consider both options. This means we use the inequality sign not equal to. So our null hypothesis is that p is equal to 0.83, and our alternative hypothesis is that p is not equal to 0.83. Let's determine if this is a left-tailed, right-tailed, or two-tailed test. Since we are being asked if the proportion has changed, and since we are using the symbol not equal to in the alternative hypothesis, this is a two-tailed test. In two-tailed tests, we must consider both the possibility that the proportion has increased and the possibility that the proportion has decreased. This is what makes it a two-tailed test. Having watched this video, you should now be able to define hypothesis testing, state the null hypothesis for all hypothesis tests, state the 3 possible alternative hypotheses for hypothesis tests, state 2 different types of population parameters that can be used in hypothesis tests, and write the null and alternative hypotheses for a hypothesis test. Please watch my other videos to see more examples of how to construct null and alternative hypotheses.